In the previous videos already we have studied how a program utilizes the main memory by dividing the memory into sections like a stack and heap. And we have also understood what is static memory allocation and what is dynamic memory allocation. Now let us move to the topic, that is introduction of data structures. In this video, I'll be giving introduction to various data structures. I have categorized them here as physical data structures and logical data structures. So first I'll explain what are physical data structures, just the introduction, then introduction to various logical data structures. Now let us look at physical data structures. These are the two physical data structures, array and linked list. We can have more physical data structure by taking the combination of these, that is array and linked list. We can have some variations in them. Basically these are two. The first thing, why I am calling them as physical? The reason is these data structure decides or defines how the memory is organized, how the memory is allocated. So let us look at them one by one. This is an array. This is directly supported by programming languages, like it is there in C language and C++, and even in Java this is directly supported. This is a collection of contiguous memory locations. All these locations are side by side. If I have an array for 7 integers, then all these places for 7 integers are together. They are at one place. This array will have fixed size. Once it is created of some size, then that size cannot be increased or decreased. So it is of fixed size. So the size of an array is static. Where this array can be created? An array can be created either inside stack or it can be created inside heap. We can have a pointer pointing to this array. So array can be created either inside stack or inside heap. Anywhere it can be created. When to use this data structure? When you are sure what is the maximum number of elements that you are going to store. If you know the length of the list, then you can go for array. Now second data structure, linked list. This is a complete dynamic data structure and it is a collection of nodes where each node contains data and linked to next node. The length of this list can grow and reduce dynamically. So it is having variable length. So as per your requirement, you can go on adding more and more nodes and add more elements, or you can reduce the size. This linked list is always created in a heap. Collection of nodes are created always in a heap. Like head may be a pointer that is pointing there, so the head pointer may be inside the stack. So linked list is always created in heap. We go with this one if you know the limit of list or the size of the list, if it is fixed, and we go with this if the size of the list is not known. So these two are physical because they define how the memory should be organized for storing the elements or for storing the data. So these are more related to memory. So I have just introduced these two data structures to you as this is a separate topic in our subject. Now let us move on to the next type of data structures, that is logical data structures. Now let us look at logical data structures. See, here are the list of logical data structures that are stack, queues, trees, graphs and hash table, and these are physical data structure already we have seen. Now let us look at the differences between them. Physical data structures are actually meant for storing the data. They will hold the data, they will actually store the data in the memory. Then when you have the list of values, you may be performing operations like inserting more values or deleting existing values or searching for the values and many more operations. Now the question is how you want to utilize those values. How you will be performing insertion and deletion. What is the discipline that you are going to follow? That discipline is defined by these data structures. That is stack, queues, trees, graphs and hash table. These are linear data structures and these are non-linear. And this may be linear or tabular data structure. Hash table, so it's a tabular data structure. Stack, this works on discipline that is LIFO, last in first out. Queue works on the discipline that is FIFO, and this is a non-linear data structure. This will be organized like a hierarchy, and this is collection of nodes and the links between the nodes. So these data structures are actually used in applications. These data structures are actually used in algorithms. And for implementing these data structures, we either use array or linked list. So this is the important point that we have to learn in this topic. That is, these logical data structures are implemented using any of these physical data structure, either array or linked list, or the combination of array and linked list. So that's all. I have given the introduction of various types of data structures. I have categorized them. This was just the introduction to give you awareness. So the conclusion of this topic is I wanted to differentiate type of data structures, that is physical data structures, array and linked list, and these are logical. And these logical data structures are implemented using physical data structures, either using array and linked list. So throughout our course, we will learn about each data structures, and we will implement them using array as well as we'll implement them using linked list. So we have to learn this. Here I have given just names of the data structure, some of the data structure. If you pick up each topic, there are a lot of subtopics in them. Like there are different type of queues, there are different type of trees, and there are different type of graphs. So each and everything we learn all those things in detail. So in our course, we will be first learning in detail about this arrays and linked list data structures. We will implement them. We will write the programs for these. Then we'll start learning about these data structure. Every data structure we will implement using array as well as linked list. So in the next video, I'll explain what is ADT and what are the various type of lists.